right. Well, we're back live again. Hopefully everyone had a decent enough break there. And it's really a pleasure to welcome Patrick and Wilson. I've been prodding these guys for a couple years. They are the only group that is a client of ours and have been a client for ours for maybe about 2.5, 3 years. So both Wilson and Patrick bring a transformation business value story of the Payzerware field management platform to the symposium today. And their expertise in enterprise data strategy and execution for improving the user experience by adopting these data-centric architecture principles is really creating a unique operational benefit, as well as other opportunities to leverage information sharing and analytics across other business groups within the larger parent company called WEX. So thank you guys again for joining us. We're ready to hear more.
Thank you, Steve. And Patrick, there we go. All right. So thank you all for joining us today. We're excited to tell you about how we're leveraging semantics at
Patrick, if you have an echo coming in, that's a feedback loop. You probably have another tab that's open. Okay, great. You're.
Are we good? Yep. All right. I'll start over. Thank you all for joining us today. We're excited to talk to you about how we're leveraging semantics at Payzer to transform the contractor's experience. So Patrick, first slide. All right, my name is Wilson Carey. I'm head of data engineering at Payzer. As you likely deduced from my title, I oversee the data engineering, but also data operations and insights functions for Payzer. I have over 20 years of experience in technology across a variety of industries and company stages. So I began in banking. I did embedded work for manufacturing. I worked at IBM, helped bring some of the first video and audio streaming services to mobile, and a little bit of everything else you can imagine running a consulting company after that. One common thread across almost all work I've ever done is data systems integration and the integration of the data within them. So I'm excited about what we've done here and the work we're going to talk to you about today. There's a picture of my family there. You can see I have 2 teenagers. So in speaking about what my hobbies are, I'm in that part of my life now where I'm pretty much a full-time chauffeur and concierge for them when I'm not working. Anybody who has kids in travel sports probably has some notion of what I'm talking about. And my co-presenter is Patrick Burke. I'll give him a chance to introduce himself.
So I'm a senior staff data engineer at Payzer with a wide background in IT, everything from enterprise client server application development back in the day at an insurance company to data warehouse design and ETL, and now data applications and AWS cloud services. I'm also an avid reader and podcast listener, all kinds of subjects, data engineering, AI, technology, and science. And when I get the time and I find something interesting, I also enjoy fantasy and science fiction.
All righty. Next slide. Advance the slide. Oh, there we go. Okay, so who are we at Payzer? So Payzer is a Charlotte, North Carolina-based software company that was established in 2012. We are a wholly owned subsidiary of WEX Inc. as of late 2023. Our target market is the specialty trades. So think HVAC, plumbing, electrical, and roofing. Simply put, our goal as a company is to simplify the business of running a business. And we began our journey to that goal as a payments processor. We're empowering our contractor customers to accept more forms of payment, to accept them in the field on their mobile devices so that they could get paid faster. But what this really led us to was the great need in that market for additional tooling to help those contractors run their businesses, which led us to build our flagship product, Payzerware. Next slide. So Payzerware is what is called a field service management platform. And what it allows our contractors to do is run their business end to end. So some of the features they have there are scheduling and dispatch, integrated customer communications, their entire sales pipeline from catalog to price book to proposals, integrated equipment and maintenance plan management, integrated reporting, invoicing, and of course the original payments and financing capabilities. What we know is that when customers really leverage the platform, they benefit in terms of becoming far more organized. That gives them the ability to empower their field technicians to be more efficient, to make it to more jobs, and to ensure that those jobs are profitable. Next slide. So what we want to talk to you guys about today is we're going to focus in on the contractor's sales pipeline and what we call the distributor opportunity. So as I just mentioned, customers who fully leverage the system enjoy the benefits of being more efficient and more profitable. And we know that in general, that because there's that friction, in order to get them there, they have to get the system set up and they need to maintain it effectively over time. And we know that that's a point of friction and something we wanted to help them with. Turns out that our distributor partners, these are the folks that our contractors are buying equipment from, they also shared this desire to solve this problem, because in every step you see here, our contractors are calling the distributor. So in the setup, they are reaching out to find out what's available, how much it costs. In the selling step, they're finding out, specifically what configuration is going to fit the job. Is it available? How much does it cost? And then, of course, the last step here for buying, after they've sold a proposal, going and purchasing what they just sold, right? And so what this amounts to is hundreds of hours of communication for basic data exchange, right? So clear value proposition for our distributor. What this means for the contractor is, this is the difference. Having this data on hand, having this data be current, is the difference between whether they can present a proposal while they're at the homeowner's house, or whether they have to do it later after doing some work, right? This is the difference of whether maybe they close that deal at all. And then, of course, in the time they're spending doing these checks, they could be going to additional jobs, right, and earning additional revenue. So the pieces, we knew this is the problem we wanted to solve, and these are the general steps of what we've done in our system. So Patrick, first one. So the first piece of this is getting the distributor's parts catalog into Payzerware. And this is more than just a list of model numbers. This is rich data. This is images, warranty information, documents, and a lot of metadata around these systems, around the specifications. In the HVAC space, there's even an extra dimension here of compatibility, in terms of when you get sold a new HVAC system at your house. That's a system, right, that has multiple components, and it's tested for certain ratings that the contractor has to adhere to. All right, the next one, Patrick. So once we have that data in the system, if you think of the catalog as where a contractor does their purchasing, the price book is where they do their selling, right? So price book, they're able to leverage this data, this high quality data, to build a more condensed menu of products that they're going to sell. This is where they enrich that data for the purposes of selling. So think of additional installation kits, thermostats. This is where they model labor and margin to make sure they're going to be making money. Again, pre-planning. All right, Patrick, give me the next two. All right. With a well-structured price book, a customer is able to create proposals and proposal comparisons. This is the customer-facing piece of their sales pipeline. Again, this is where having high-quality data is just critical. The better the data, the better the presentation, allows them to really close those deals more effectively. And give me one more, Patrick. Using Payzer, those customers can then accept those proposals. What they call them closing it at the kitchen counter is what we call it. So again, the more that data is on hand and ready to go, the more they can close those deals with confidence. And then the last one, Patrick. We want to make sure that what our contractor sells, they can easily turn into a purchase order that they can file electronically. And it's not shown here, but when a contractor uses the system this way, everything they obtain via the electronic purchase order can be pushed into the equipment management section that I mentioned earlier. So we knew this is what we wanted to do. And so we set out on doing it. So next slide, Patrick. And all in all, things started off well. We ran into some interesting challenges along the way, most of which fall into the genre of just variations between partners. So, fortunately or unfortunately, however you look at it, the first distributor we integrated with had very strong investments in their digital assets as well as their system to fairly straightforward. We would acquire data from them by API. It would go into a data pipeline for cleansing and enrichment and transformation for storage, and then we would serve it by a middleware, but it was a silo. Each integration was a silo. It wasn't until we reached some of our next partners that we started to see some of the limitations of that implementation. So a future integration we did, a partner had very little to bring to the table. They did not have strong investments in their digital assets or integration, but they were part of a group that did, right? Or they had a situation where, they're a reseller of a manufacturer and that manufacturer had assets that could be used. And so this was the first time we encountered this notion that some level of sharing of assets was not only acceptable, but desirable for creating experiences for some of those distributors with smaller investments in it. And it didn't violate the policies of one distributor who had put more investment in versus another. The next interesting situation we ran into that started to really keep developing this picture for us was the next distributor who did have a strong investment, but we found that they did things a lot differently. The conventions were different. So while a lot of the obvious stuff lined up, like model numbers and things like that, as you got into more of that extended metadata, you'd get into little nuances per brand where they were using different conventions to describe the same concepts. And at the nth degree of that, you'd have two distributors who are selling a common piece of equipment from the same manufacturer, and they would describe it very differently. So we ended up with, multiple representations of the same piece of equipment but in multiple silos, so no connectivity to them. And then the last scenario that really kind of tipped it over for us that we needed to rethink things was the notion that within our distributors, they had lots of locations, and those locations had a high degree of autonomy in the way they did business. And what they position, as well as particularly in HVAC, contractors, pricing is largely negotiated, right? So you've got a high degree of variation in pricing people get, and that can vary based on size of contractor. Some of them may have arrangements with manufacturers for special pricing that is honored by the distributor. The takeaway at that point, though, for us was that we realized none of our customers were actually using the data we were collecting as is. Everybody, with rare exception, largely had a custom asset in some way. And the way to think about that was you had this equipment, this catalog of equipment that was a series of layers to reach the final product to be displayed to the user. And those layers were coming from multiple sources or multiple silos in the environment we had built. And we realized that we were no longer in a good situation to model this and move this forward. So we started to evaluate how we were going to do this differently. And with that, I'm going to hand it to Patrick to discuss our solution.
So the core of our architecture is an RDFox triple store for storing our RDF. It's a high-performance in-memory triple store from Oxford Semantic Technologies, which was acquired recently by Samsung. Of course, because it's RDF, it's schemaless. And one way to think about it, I guess, is it's schemaless. It's very flexible. When Wilson was talking about these different suppliers having different metadata about their products, we were able to accommodate that in this RDF structure. RDF flexibly models the relationships between the two core pieces of data that we have, which is the various products that we're selling and the HVAC bundles. The bundles being, you can imagine with an HVAC system, you're going to have like an indoor unit and an outdoor unit. Those are completely different SKUs and potentially even a furnace. And then, when you sell it, there could be even more things involved. One thing that was really important for us is this is a user-facing data application, which is kind of unusual. So it's not like a data warehouse where we could have queries take minutes to run. So that's one of the things that led us to RDFox. Their in-memory architecture ensures that we have rapid responses to our queries. We're also able to model, even with all of these different ways that suppliers model their data, the various facets of the product features. So that was a huge benefit to us in going to a triple store. And of course, it does come with challenges. But before I get to that, one other point that on the RDFox triple store side that led us to going in this direction was it also has data log rules. And data log, there's an example there on the screen of a data log rule. So it allows us to drive new triples using data log that is very performant when you go to query the database system. And so now the challenge is, of course, there's always going to be some. It's in memory, so we had to be careful about the amount of data that we were loading into our RDFox triple store. You'll see in a moment that we chose to load some of our other data that's much larger into a different database. And also, it only supports OWL2 RL. Which is a subset of the OWL2 full. And if, we, working with Semantic Arts, modeled our data using OWL full, and then we needed to do some translation of that to OWL-RL. Otherwise, those things that are not supported by OWL2 RL would not get imported into the triple store. So that was one of the challenges that we faced. You can see also a screenshot there of the RDFox web UI for running a query. It's just a sample query there. So good old SQL database. This worked really well for our pricing data. You can see the structure there, very simple, straightforward. We didn't really need to leverage a graph data database for this because we weren't really dealing with different types of metadata from these various suppliers. So, and the fact that, as I mentioned earlier, we have, in this case for pricing, we have relatively, not huge, but relatively larger amounts of data that we wouldn't want to have to store in memory and grow these large instances just to store this data in memory. And also another difference is that, while the product and bundle data is much more slow churning in terms of updates. Pricing data, as you can imagine, can be updated a lot more often. So we needed a way to update that without having to go through an entire graph update. So this fit our needs for this pricing data much better. It did have some performance challenges at the beginning. You can see here we partitioned the table, and that's actually just one level of partitioning that we had to do in order to get the query performance that we needed. Remember, this is a user-facing system, so we need sub-second and preferably sub-half second queries. So this is just one of 3 different systems that has to be queried. So we need very fast response times from all of these systems. Another challenge was data loading. Loading into PostgreSQL is a lot slower than loading into the graph, partially just because of the volume of the data. But we've managed to get that to a tolerable level. One of the key features of our system, we have a web UI where our users can write queries just like you would, in Amazon or some other website like a Lowe's, where you're searching for products. It's a text field that you can just type in natural language queries. It's a live search, so after I think the first 3 characters, we start showing results, and every character after that, we continue to show the updated results. So Solr is great for this kind of querying. It allows you to configure exactly what fields you want to search, fine-tune that search behavior with the tokenizers you want to use per field, filters for stemming and n-grams, and lots more. So it is really the heart, when people are interacting with our system, of what they experience in terms of search. You can see an example of a Solr query through the web UI from Solr. This isn't what our users would see, but if we're working with Solr to work on our queries, that's the interface we would use. And you can also see a quick snapshot over there in the corner of partially of what the schema looks like for our searching. So that also brings up the challenges. So again, it's very flexible, but that means you need to understand what those options are and how to use them to get the kind of search results, the relevancy that you're expecting, that your users are expecting. So this required coming up to speed on search and information retrieval, as well as even Java JVM tuning for optimal performance, to make sure that when we did updates to the index that we didn't have problems with memory. So one challenge, keeping in mind, now we're talking about our architecture as a whole for our database systems, at least on the back end. We've got 3 different systems, and so we have to keep these all in sync. And in particular, since our SQL database, PostgreSQL, is getting updated on a fairly regular basis, we have to make sure that it's kept in sync with Solr to only show the products that people are able to purchase. So that is and has been a big challenge. That was one of our bigger challenges in getting this extensive system up and running with these 3 data systems. And in terms of architecture, one other thing to mention is, of course, our Payzer integration. So this is a snapshot of the screen that a user would see when they're looking at the bundles that are available to them in HVAC. And you can see an example of some of the features that they can use to narrow down their search. And you can see some search results down there. So again, remember, this is a live search. So as they're typing in and picking, facets, they're getting the search narrowed down as they go along. Behind the scenes here, what you're not seeing is something that we went with, because this isn't the only Payzerware web GUI that's using these data services. So we decided to make this a little more developer friendly, to make the developer experience better, so they didn't have to particularly, have to learn the details, let's say, of Sparkle queries or Solr queries. So we created a middleware service we call the SDS, the Supplier Data Service, And so based on the API, it goes ahead and generates queries for all of these systems. It combines the results and returns that back to the web UI that submitted the API request. Want to definitely note that the collaboration with Semantic Arts was key to creating an ontology that accurately reflects the knowledge domain of our suppliers. With their help, we developed a supplier ontology to represent the concepts and relationships within the Payzer product, and particularly the HVAC domain, and especially the bundles that I talked about. They can be quite complex. The ontology provides a structured framework for understanding and reasoning about suppliers, products, bundles, and all of their attributes, which again can be completely different across suppliers. In addition to the core product ontology, and you see a quick snapshot there of one aspect of that core product ontology. But in addition to that, they also helped us to create over 20 vocabularies and taxonomies, as well as validation, Tarkle, which we'll talk about next, and data log scripts. And a big part of this, you can see a quick snapshot there of the GIST upper ontology. So the creation of our ontology, we were able to leverage GIST, and that provided a great general conceptual framework for modeling the entities of our system. Another big area Semantic Arts was instrumental in was in helping us to come up to speed on Sparkle. It has some things that seem similar to SQL, but you realize right away you're not in SQL anymore, and things get out of hand pretty quickly if you don't have someone to bounce things off of. So they were absolutely great in helping us to come up to speed quickly and understand how to do our own Sparkle queries, and helping us to write our Sparkle queries for our ETL, and just for doing validation and other things. One challenge that we ran into was that having fewer predicates in our ontology based off of GIST is definitely handy to conceptualize that ontology, but it can make, as you can see, this is just a small portion of an entire, very much longer query here that goes on for, this is like maybe 1/3 of the query. You can get very verbose queries. And so we worked with Semantic Arts to create what we ended up calling shortcut predicates to make some of these queries a little bit more succinct and easier to write and easier to understand. And one of the latest things that we've been working with them on is the vocabulary editor, because once you have these vocabularies in place, you might populate them with some default data, but as time goes on and you need to continue to keep these updated, and you need to reconcile different data representations, it's a challenge. And so we've worked with them to create a textual user interface system. It's based off of a Python library called Textual, and I really like what they've come up with. And it's helping us to be able to maintain our vocabularies. As I mentioned, even though this is a user-facing application, this is very much a data application. So we have an extensive amount of ETL, and this involved tools, more than one, which we'll look at, and numerous challenges. So the first thing is Tarkle, which is just a great tool. If you're doing any kind of conversion of data from a tabular format into RDF, in many cases, this will be a great fit. It's easy to use once you understand Sparkle, because that's what it's using. It's using a Sparkle construct query here. You can see an example of part of it, both the construct clause and the where clause. As you can see, you've got in the where clause, you've got access to various Sparkle functions that you can use to manipulate the data coming from the CSV data that you're processing. One of the big benefits of using Tarkle, it's quite fast because it's based off of Java. So chunking through large amounts of data, it goes through that very quickly and it works really well. Even there, though, you've got to keep in mind how much memory you've got on the particular EC2 instance that you're spinning up to process this data. And so we've ended up chunking that data to make sure that we didn't blow out our memory. So the challenges, well, Java is great because it's fast. Also means that you have to deal with making sure you've got Java installed. And you need to maybe tweak some JVM settings. We had to do that to manage our memory better. And then in terms of integration, you could just shell out. Tarkle is first and foremost a CLI command line tool, but you can directly integrate with the Java code. And since we're using Python, we chose to use JPipe, a Python library, to directly integrate with that code to interact with the Java shells and functions. RDF Lib is another way that you can go if you're using Python. This is a Python library. We leverage this in our more complex data conversions. You've got the full power of Python to loop through things, to go through multiple levels as necessary. And you can see it's fairly straightforward to understand. You can pretty much, once you get to know how Turtle works, one of the languages we're working with RDF, this becomes pretty straightforward to understand what's going on here. One of the challenges, though, is we couldn't do everything in RDF Lib. It is in Python, and so for larger amounts of data, it's not a great choice. And what that means in terms of your particular environment and how much time you want to allocate for ETL, how much time you have available to do that. If it's real time, that's definitely a concern, or offline batch processing. But it's definitely a challenge to keep in mind. And definitely want to just briefly touch on the idea of things versus strings. This is one of the things that attracted us to the idea of a knowledge graph. So for all of the subjects and objects in these predicates, these triples that you're dealing with, you need to generate IRIs for these. And at first, my thought was, well, that's not that big of a deal. You're going to just use some kind of unique value that you have from the source system, like a product identifier, and that'll allow you to produce unique IRIs. But you have to keep in mind that, essentially you're modeling, there's like a sixth normal form in SQL, where basically every column gets its own table. And that's one way of looking at what you're doing with RDF. You've got basically your data exploded into individual columns. And so if you think about that, now you've got to have this unique identifier for essentially what's every column in your database. And so that's a bit of a challenge when you have columns that don't necessarily have, some unique identifier. And we needed unique and deterministic generation. We couldn't just randomly generate IRIs because we've got different pipelines. And based off of the string, we needed to make sure that each pipeline was going to generate the same IRI, so that this data, when it went into when the RDF was loaded into the triple store, that those IRIs would essentially snap together. So that was a unique challenge for us because you've got different strings, like say for units of measure, that mean the same thing, but you want them to be mapped to the same thing. In our case, we had issues with non-ASCII characters. I don't know if that would be the case in all environments, but if you want your IRIs to be meaningful, do you really want to have, say, a Unicode degree symbol or a trademark symbol in your IRI? It's just a decision you have to make. And then, of course, weird things in the data where you have HTML Unicode like ampersand, pound, some Unicode coming from, probably somebody cut and pasted from, say, a spreadsheet or something like that, the data. So there was a lot of, and we still deal with a lot of data cleanup like that. So that was definitely a challenge. Just briefly want to touch on this. This is the Python-based data orchestrator, Dagster. I know many people are familiar with Airflow, but we really liked Dagster, and it seemed to really address some of the pain points that I've experienced in the past with Airflow. And so this handles our ETL jobs, our batch jobs, as well as our online real-time jobs that we run. So that's great. You can run it locally for your testing and development of your ETL jobs with what are called DAGs, directed acyclical graphs, that encompass all the steps for the processing that you need to do. And then we have it deployed on AWS as an ECS cluster that dynamically launches and shuts down EC2 machines to run each job within its own dedicated EC2 instance. So just to finally touch on the future, we're excited about what our investment in graph technology is going to allow us to look forward to in the future. So semantic search, specifically RAG search, is very much in the forefront of people's minds at the moment with AI. And there's a lot of literature coming out, papers talking about how using graphs to in conjunction with RAG is getting great results. So we're looking forward to experimenting with that and see how that goes. Even looking at model fine tuning with the graph data is something we're going to definitely want to investigate. And also I mentioned the challenges of parsing our data. And this is something that we're seeing a lot of people leveraging these systems of LLMs and the semantic vectors that you can generate from these that give you these one-shot ETL parsing that you can use. It's going to definitely require some work, but it's something that we want to explore. That will probably improve our parsing quite a bit. And then that leads to even RDF generation using AIs and AI models in our graph data. So that's where we're planning on investigating going in the future with what we've got so far.
Thank you, Patrick and Wilson. This has been a fantastic learning experience. And as you said, associated with these types of complexities, there are challenges. And certainly, as we've heard from other presenters, is that experimentation and refinement is part of the deal, right? And we do have a question here from Samuel. If you wanted to read that, I don't know who wanted to field that question, but that's one. I got a couple others, and then we'll close things up.
Yep, I'll take this one. So Samuel's question is the ability to see where some parts or components or SKUs of the larger system have the same manufacturer has a lot of value across multiple scenarios. Have you explored other uses for this type of data? Were there challenges in getting access to company manufacturer data? So yes, there were lots of challenges in getting access to the data. A lot of it relationship based, just kind of getting policies in place and getting things up. And then the second part is what I mentioned earlier on, just the range of capabilities varied quite a bit. This market or this industry in terms of really rallying around the value of digital assets and the ability to exchange data has been rapidly evolving. It's far further along now than it was, but yeah, that's come along. And then in terms of are we exploring other avenues for this? Absolutely. Patrick mentioned it at the end there, but we absolutely know we've made a smart investment here for the future, for where the capabilities are going. managed to move this into different parts of our application, and now we're part of a larger company as well. So there's other opportunities we've explored, and then we've also had discussions upstream, right, where talking to some of the people supplying us data and saying, hey, here's maybe some other ways to think about how we could do this. So I think there's opportunities in both directions for sure.
Yeah, and at a business level too, I know that the search feature was something that was really involved with enhancing the user experience. And what has been the responses overall? I mean, what has been that feedback? I know sometimes these types of things are difficult to put a quantifiable metric on, but you guys have probably gotten some reactions as to what they're saying, and needless to say, the pursuit is moving forward. But what were some of those reactions?
Very positive. We led with facets, of course, right? We wanted to give everybody the faceted experience, but everybody's very trained on the Google text box, right? So
Yep.
it's we needed to have both, and that was, we were just ahead of the boom in LLMs, right? Where the challenge of getting anything somebody might say into meaningful facets was still somewhat difficult. So we are excited about continuing to iterate in that arena. And leverage some of the improvements there, but there's been movement there. We have more capabilities to leverage from Solar and other tools in our ecosystem, so it's continuing to move. But yeah, it was a major improvement. It was like you said, you have to try some things out to see what users are going to respond to.
In architecturally, you feel that you're in a really good place for this more or less extension and having that flexibility and that baseline of concepts at this point. What other use cases do you have in mind?
So we are again spreading it out into more parts of our existing ecosystem, right? So helping, we want to help our contractors more personalization of the interface, and then starting to actually grow to other audiences that are part of this value chain that I can't speak to too much, but this sets us up well to make sure the data is organized. I think it was mentioned in an earlier session, AI. And what's happening, it has to have your data has to be organized to leverage it, right, and to have it be meaningful. So we feel like we're in a great position for that.
Yeah, and Michael had a question. I think we tapped on one of the value propositions for the users, but was there any other real recognizable things that came about after you kind of changed the architecture, went to this more federated and search appealing model?
I mean, largely just our ability to do it. We would come into scenarios where we needed to pull data across silos in ways we hadn't expected, and it led to an unpredictable amount of time to deliver that experience, maintain that experience. And so this put us into the realm of being able to do it and deliver. Again, it's the higher quality the data we can put in the system, we're saving our user built on their own too, right? So speed to value, overall value of the tool for them, and then of course the fact that it's dynamic is a game changer too, right? It's it really challenges some of the models of averaging things out because you just couldn't get the data fast enough.
Right.
Now you can, right? So we're really helping them out, and have had a good response to it.
Outstanding. Well, thank you again, Patrick Wilson. Really appreciate it. Joaquin, how are we doing on time? Are we taking a small break, or what's the story? You're on mute, my friend.
Shucks. We have a 1-minute break coming up, and then we're going to have a very special introduction to upper ontologies, otherwise referred to as foundational ontologies. So if you want to take a quick break and come back in about 10 minutes, we'll be right back with the next presentation. Wilson, Patrick, thank you very much for coming on by and sharing your knowledge, sharing the tech stack. This is what grows the community. So thank you.
Thank Thank you.